My name is Karasoni and my topic is TLB, Translocation Lookaside Buffer. The TLB is a specialized cache that stores the most recently used virtual to a physical address translation. By maintaining a cache to this translation, the process can be quickly look up for the physical address corresponding to a given virtual address without having to perform a full address translation through a operating system page tables. This scientifically reduces the time and the resources required for the memory access, improving overall system performance. Uh, Purpose of TLB. First is faster address translation. The primary purpose of the TLB is accelerate to process of translation virtual addresses into physical addresses, which is critical step memory management. By catching this translation, the process can be quickly look up the corresponding physical addresses, reducing the time required for each memory access. Second, improved memory access performance. By reducing the time and resources required for the address translation, the translation localized buffer help to improve the overall performance of memory access, which is crucial for the application that frequently access memory, such as databases, web servers, and the scientific computer workloads. The third is reduce memory management overhead. The TLB offload a scientific portion of the address translation process from the operating system, reducing the overhead association with the memory management task and allowing the CPU to focus on the executing instruction more efficiently. Structure and organization of TLB. First is associative cache. The TLB is typically organized as a associative cache, which means that the cache entries are not arranged in a fixed linear structure. Instead, each cache entry can be associated with a physical address, allowing the more flexible and efficient storage of address translation. Second is content addresses memory. The TLB uses a content address memory CAM structure, which allows for rapid lookup of address translation. When a virtual address is presented to the TLB, the entire cache is searched in a parallel to find a corresponding physical address rather than sequentially searching through a linear array. The third is multi-level organization. Modern CPUs often feature a multi-level TLB hierarchy, which are small, fast, and highly associative first level TLB. L1 is representing the first level of TLB, and the largest lower and the less associative second level TLB. The hierarchical organization help to balance the trade of the between sizes, speed, and associativity. TLB lookup process. First is virtual addresses. The processor present a virtual address to the TLB which represent the address that the program or application is using access memory. Second is TLB lookups. The TLB performs a parallel search for the entries of the find the physical address of the corresponding to given virtual address. The TLB process is extremely fast thanks to the TLB contains address memory CAM structure. Third is miss or hit. If the TLB contains is a valid entry at the virtual address, the TLB hit. The corresponding physical address is written and the caches can be processed. If the TLB does not contain the valid entry, a TLB miss. The system must have performed a full address translation to use the operation system's page tables. TLB misses and handling. If the TLB miss, the handling is such a way that we are studying in. TLB miss. First is TLB miss occurs when a TLB does not contain a valid entry for the virtual address being processed. This trigger a more expensive address translation process where the operating system pages tables must be consulted to find corresponding physical addresses. Second is page table lookups. When a TLB miss occurs, the process must perform a page table lookup to translate the virtual address. This involves accessing the system main memory, which is significantly slower than a TLB hit, leading to increased memory access latencies and reduced system performance. Third is TLB miss handling. The to handle TLB misses, the process typically invokes a special exception handle, which is responsible for the performing the necessary page lookups and updating the TLB with the new translation. The process adds additional overhead to the memory access. Next is TLB performance optimization. larger TLB. Increase the size of the TLB, particular of the L1 TLB, can reduce the frequency of the TLB misses and improve overall performance. Larger TLB can be store more address translations, reducing the need of the expensive pages lookups. Second is higher associativity. Improve the associativity of a TLB, which determine the flexibility of the cache replacement policy, can be enhanced performance by reducing the likelihood of efficient useful translation during the cache replacement. Third is multi-level TLB. Implementing a multi-level TLB hierarchy with a small and fast at L1 TLB and a larger L2 TLB can help balance the trades off between size, speed, associativity, leading the better overall performance. Fourth is TLB prefetching. Technique like TLB prefetching, which proactively load the translation into the TLB before they needed, they can further reducing the frequency of the TLB misses and improve system responsiveness. Last is application and importance of TLB. Memory extensive application. The TLB are particularly important for memory intention application such as databases, web servers, and the scientific computing workload where frequent memory access is critical by performance accelerated address translation. TLB can significantly improve the responsiveness and throughout the this application. Second is virtualized environment. In virtualized environment where multiple operating systems or virtual machines say share the same physical hardware, TLB plays a virtual role in maintaining efficient memory access. The TLB help to is isolate the address translation of different virtual machine, improving the overall performance of the system and security. Third is real-time system. A real-time system where the predictable and the low latencies memory access is critical. TLBs help to ensure the memory operation can be implemented with the strict and consult in enabling these systems to meet their performance or requirement. Thank you. Slide.